Alright, let's go ahead and get started. Let me move a couple things around my office to get set up. Get my drawing pad ready. There it is. Alright. So we're going to get started with question 1, which is this circuit was the current in this circuit. We got a lot of people saying 4 amps, so let's see. Let's open this with what properties? Opens with paint. Let's open, yeah. Alright, let's resize it, make it a little bit bigger so we can see it. Alright, now we're going to work this circuit. Pretty simple circuit. Alright, so let's start out with drawing our chart. It's been a minute, so this is a good one to start with. So we have our total, R1 and R2, I total, I1 and I2, E total, E1 and E2, and E2, and then I might have to adjust where some of these fall. P1 and P2. I almost ran out of board. Okay, we know R1 is 27 ohms. We know R2 is 18 ohms. We know E total is 180 volts. And I feel like this one's going to run a little long, like this whole lesson. I'm going to take a minute in the middle of it to, I probably won't. I was going to say I'm going to take a minute and put up the old lesson. Alright, so in this circuit, you're going to look for 2 things on any of the rows. You don't have 2 things on any of the rows, so let's move on to our total. We can combine things based on the columns. This column has everything but the total, so we can just add these 2 together because resistance in series adds together. So 27 and 18. Let's just grab a calculator. 7 plus 18 is 45. We have 45 ohms. Next up, now that we've got 2 things on this row, we can, that's my alarm for, hey John, you forgot to go live. Alright, so 45 and 180. Well, 180 divided by 45, so E divided by R will give you I. Let's write that circle down here. That is the Ohm's law circle that you should have seen a few times at this point. Alright. Oh, calculator. So this is 180 divided by 45 will give us 4 amps. Now let's not stop there. So in a series circuit, current is the same at all points. So all currents are equal. So 4 amps and 4 amps. So now all we have to do is multiply across, because R times I gives you E. So that gives us a calculator. 27 times 4 is 108. And we don't have to multiply across here. We could, but we don't have to, because the voltage, like the individual voltages, will add up to the voltage total. So in series, your voltages add up. So 180 minus 108 will give us the other one, which would be 72 volts. Alright, and then now to get our last row, which is the powers, which is pretty much the last thing you can find, we're going to take our I total, so our other circle that we're going to use is P I E. So power is equal to I times E. So power is equal to current times voltage, not current. So 4 times 180. Oh, I hit it twice. It's not 129,000. It's 720. That's watts. Then we'll do the next one. 4 times 108. 432. And powers in series. Power always adds up. We just did that in the last lesson. You can see that there. And then let's do that last one. 4 times 72. 288. All right. That is our first question. Okay, and we already answered was voltage drop across R1 because we did the whole circuit. Yes, I'm still live. All right. Moving on to the next circuit. Let's open that one up. All right, we have our total. Just draw out our chart. We only have one thing, so this will be pretty quick. I total, E total, and P total. I don't remember what the question was asking, but we have 5 amps and 220 volts. So 5 times 220, 1100. watts. And then 220 divided by 5 will give us 44 ohms. And that's got this whole circuit solved. Since it was only one component in the whole circuit, you just use Ohm's law. I'm going to write those down again. I'm going to be smart and use the circle tool. And then magic. Okay. Now we'll mess it up with our handwriting. That's E-R-I and P-I-E. Erie and pi. Those are the two formulas you really need. There are obviously way more formulas, but those are the two big ones. Okay. Let's move along. We found total power. We found total resistance. Hey! Y'all nailed this one. And y'all did pretty good on this one. Somebody put 110 amp or 1100 amps. Somebody just put the voltage down. That's weird. Alright. What is total voltage in this circuit? I'm not even putting this one on the... Well, maybe I will. Nope. We only got one question about it. So, voltages in series add together. So, voltage sources in series add together. The total voltage in this circuit is 12. 12, 12, 12, 120. That's weird. 12, 12, 12, 12, 12. 36. I mean, that looks like they multiplied them together. Alright. That's weird. Sometimes I want to look at the names of these, like, who in the world thought that was the right answer? But I don't want to call anybody out on the stream. I'll look in a minute. Okay, what is total power in this circuit? So let's work this one. This is that circuit. Hey, what the hell? Let's open with paint. Alright, let's get started. Ooh, that was a bad R. Need to work on that. Oh, that's a much better R. R, I, E, and P. Three, 4, and 5. I'm getting better at this. Alright, one. Oh, need to change my pen size. That's total 1, 2, 3, 4. Oh, I miscounted. 1, 2, 3, and 4. Total 1, 2, 3, and 4. Total 1, 2, 3, and 4. Okay. So we got 10 ohms, 16 ohms, 8 ohms, and 11 ohms. Then 12 volts. So, first off, we're going to add all these together. I believe this is 34 445. Let's see. Plus 16 plus 8 plus 11. 51. Did I do that? Oh, I didn't. 10 plus 16 plus 8 plus 11. 45. Okay. Alright, so now we've got two things on a row. We're going to divide. 12 divided by 45 is 0.267. Alright, 0.267 all the way down. And now we just have to multiply across to get our voltages. So this one's pretty easy. 10 times 0.267, that's going to be 2.67. These are all amps. I could have written that before I copied it. This is 2.67 volts. 16 times 2.67, 42.72. That's not it, is it? Oh, 0.267. That's going to be 4.272 volts. The next one's going to be half, because it's half the resistance, so it's going to get half the voltage. That's going to be 2.1 what 35 volts, and then 11 times 0.267, 2.937. All right, and then rinse and repeat, do it all again. 0.267 times 12, 3.204. And in the interest of time, I'm not going to do all of these. We're just going to move on, because all we cared about was total power. Okay, what is voltage drop across resistor 2? Oh, that one's going to be blurry as hell. Alright, what is voltage drop across resistor 2? Well, this is a parallel circuit. So we have R total, R1, R2, I total, I1, I2, E total, E1, E2, and P total, P1, and P2. So we've got 30 ohms and 75 ohms, and we have 0.5 amps. So our first step, we got two things on a row, so let's do that. 30 times 0.5 is, it's either 15 or 60. I always screw this up. Yeah, it's 15. 15 volts. This is parallel. And in parallel, voltage is the same. So 15 volts and 15 volts. Sorry, the vacuum was distracting me. Alright, so now that we've got all our voltages, we can 15 divided by 75 will give us our other amperage. .2. And in parallel, amperages add up. So we are at 0.7 amps. And this is where there's an easy way to get resistance total. I want to show you the correct way to get resistance total. If I just started out with asking you what is resistance total, that's going to be the reciprocal method, which is R total is equal to 1 over R1 plus 1 over R2. There's an easier way to put this in your calculator. You open parentheses, R1, then you use the x to the negative 1 button, plus R2, x to the negative 1 button, and then give one more x to the negative, or x to the negative 1 button. So we have, let's type this into our calculator. Open parentheses, 30, and ignore what is going to pop up as we go. X to the negative 1 plus 75, x to the negative 1, close parentheses, one more x to the negative 1. So 21.43. So let's see what doing it the other way gives us. Where is my mouse? There it is. We got 21.43. Let's do 15 divided by 0.7. Exactly the same number. Wow, all the way out to like the smallest digits too. Alright, so let's go ahead and find our powers just for completionism. 15 times 0.7, 10.5. That's going to be 7.5 and 3. Just doing the math in my head. Alright. And that is this circuit. Dun 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 dun. Again, I can't find my mouse. Alright. So, the question was, what is voltage across R2? That is 15 volts. I don't think I'm doing this right. I'm going to wait for stream. Alright. At least they're honest. I think only like one person got 15 volts. 2 people. Okay. Some people just chipped in 14 volts. Good job. What is total voltage in this circuit? So we got 10 volts, 10 volts, and 10 volts in parallel. Well, total voltage is 10 in this particular one. Voltages in parallel do not add up. they share the capacity. So 10 volts. Alright, good job, guys. What is current draw from each battery in this circuit? So, first off, you need to know the total current draw in this circuit, which is 1 amp, because you have 10 volts total. That didn't make it bigger. You have 10 volts total and 10 ohms total. So you have a total of 1 amp. So the actual current draw from each battery is going to be a third of the total current draw. So you'll have 0.33 amps right there. So good job. Somebody 3 amps. Went the wrong way, but at least you're consistent. I know I didn't put any answers in here. Yeah. What's the total power in this circuit? Alright, now we have a parallel circuit, 28 and 70. Is that the... that doesn't happen to be... Okay, 30 and 75. I was like, I didn't give y'all the same circuit twice. That would have been super convenient. I would have been able to go, well, not working this one. Alright. Alright, paint. Of 100%. Oh, that's garbage. That looks terrible. Let's... Alright. We have our total, R1 and R2. I total, I1 and I2. E total, E1, E2, and power total, power 1 and power 2. There are several ways you can go about doing this one. 98 volts. 28 ohms and 70 ohms. So that's all the information we start with. You could, since it's 98 volts and 98 volts, do this the long way around of finding your currents and getting current total and then finding everything from there. That's probably the easier of the two ways. I'm going to do reciprocal method, which will be open parentheses 28 to the -1 plus 70 to the -1 and then another -1. So let's open parentheses 28. Let's clear everything. Open parentheses 28 plus 70, and then one last one. So 20. 20 ohms. Now we go 98 divided by 20 gives us 4.9. Then times 4.9 times 98 will give us 480.2 watts. Alright, 480.2 watts is the answer. I think I just saw one pop up. Alright, what is the voltage across R3? Yeah, we'll work that one. Well, the voltage across R3 should be pretty simple, actually. That's the wrong button. If it's, oh, this is combination. Okay. How many we got left? Okay. 2 more circuits. Let's work this circuit. Let me find it right there. Open with paint. That's actually a pretty good size. R2 and R3. I total I1, I2, and I3. E total E1, E2, E3. And then finally, power total, power 1, power 2, and power 3. Let's record our values. 10, 20, and 40. These are ohms, these are ohms, these are ohms. And we have 12 volts total. So our first thing, we're going to combine R2 and R3. Make that have a separation. So you want to separate these 2 rows. And let's work smarter. Alright, so combining 20 and 40, again that's using the reciprocal method. That's it right there. I'm trying to write it down because that's what trips a lot of people up. Plus 40, 13.33. Alright, so that makes our... So, now that we've combined that together, we're going to redraw the circuit. And that's R1 right there. Then R2, 3 right there. So you can see this is just a series circuit, and we'll work it like that. R1 and R2, 3 combined together to get our total. So that's going to be 23.33 ohms. And now we can start working the circuit in earnest. $12 divided by 23.33, because it's just a series circuit, or we're just doing Ohm's law. 0.514. 0.514 amps. And so all the resistors in this series circuit have 0.514 amps. So it's going to be R1 has 0.514 amps, and I23 is going to be 0.514 amps. So now we can do Ohm's law again. to work through this circuit. Times 0.514. Okay, I should have known that one. 5.14 volts. And clear. 13.33 times 0.514. 6.85. And since these two R23 was two parallel resistors, we get to keep the voltage. So this voltage right here, the 6.85, goes up here. 6.85 volts and 6.85 volts. And that is it. So now we can take 6.85 and divide it by 20.342. And then we can do the same thing with 40. .171. All right, and now we can just multiply across to find power. Okay, we do need to find power. Five, 1, 4, 6.16. All right. All right, then all right, so we have, what is the voltage drop across R4? Okay, so we've got a parallel circuit. It's actually going to be half, so it's just looking at it, half of the voltage. So it should be about 6. Okay, so let's redraw, like, circuit 1, open a new one. Don't save. Let's redraw this circuit so it's a little bit easier to see what's going on. Alright, so here is our, oh, I don't know how they're numbered. Hang on. R1, 2, 3, 4. Okay. R1 is 10. R2 is 20. And then you've got another pair. R3 is 20. And R4 is 10. So we only have to do our math once. Open parentheses, 10 power of -1 plus 20 to the power of -1, 6.67. So these combine to make a 6.67 ohm resistor. And it's two identical pairs of resistors, so you get .67 and 6.67. ohms. So your R total is going to be what, 13.34. 6.67 ohms. And then our voltage was something. We had voltage 13.34. Did they really? Yep. Voltage E total is 13.34 volts. So I is going to be 1. I12 is 1 amp. I3, 4 is 1 amp. Sorry if this is getting a little sloppy. I'm trying to hurry. I know y'all got places to be. All right. So 6.67 times 1 is 6.67 volts. And then 6.67 volts because they're both identical. And now, since they were asking about voltage drop, you split them apart, and since they were parallel, it's the same voltage, so it's going to be 6.67 volts all the way around. Everything has 6.67 volts. What is total power in this circuit? Well, since we have all the all the pieces, it's actually going to be 13.34 watts, because 1 times 13.34 is 13.34. Alright, thank you guys for bearing with me. I will see you guys at 2 o'clock. I'm going to put up a new quiz. Be sure to go finish your tests. Loading quizzes. So, not one attempt. Alright guys, I will see you guys in a couple hours.